All right, hello. So today we're going to do our next section, section 8.1. And as usual, we're going to start with pre-class. So at this time, if you could go ahead and work on the two pre-class questions. And when you're finished, please enter your answers on the Edpuzzle if you're watching this on Edpuzzle. For those of you who have finished, okay, let's go ahead and check our answers. So for number one, the answer for pre-class should be y equals 22.5. So if you remember here, this is review. When you see the words y varies directly with x, what you should write is y equals ax. And that's your equation. And then remember, you're going to use the information to solve for a. So you're going to use y equals 36 equals a times 8. Solving, you get a equals 36 divided by 8. And then you substitute that back into your equation, and that's how you get y equals 36 over 8 times x. And then finally, y equals 36 over 8 times 5. And that's where you get 22.5. All right, for number two, if you travel at a constant speed, the distance you travel varies directly with the time. If you travel 182 miles in 3.5 hours, how far will you travel in the same constant speed in 5 hours? So again, you travel constant speed. So the distance you travel, distance varies directly with time, AT. So if I travel 182 miles, so 182 equals a times 3.5. We divide, so we get a equals 182 divided by 3.5, and I get 52. So we have d equals 52t, so we have d equals 52 times 5, and that is where we get 260. So your answer for that one should have been 260 miles. Okay. All right, so let's make sure you have both of those answers for your pre-classes. Now moving on, section 8.1, this title of the section, Model Inverse and Joint Variations. So it's slightly different than what we've done with direct variation. So our key concept here, you have learned that two variables, x and y, you have learned that two variables, x and y, show direct variation if y equals ax. So it was the equation from pre-class for some non-zero constant a. Another type of variation is called inverse variation. So that's what we're going to study in this section. So two variables, x and y, show inverse variation if they are related as follows. So you see we have a new equation, y equals a divided by x. So our equation changes with inverse variation. Again, a is a constant, and it's called the constant of variation. So we're going to use a similar process to solve for a in this section. All right, so here's example one. We're going to tell whether x and y show direct variation, inverse variation, or neither. All right, so basically what I like to do is, can I solve for y? So y equals 3x in the first one. Notice how that is in the form y equals ax. So therefore, this is what we call direct variation. Okay. All right, in part B, we can interchange the variables x and y, using some algebra here, and you get our same format, y equals a over x. So that's in the form of inverse variation. And then finally, we have x plus y equals 5. So we have y equals 5 minus x. It's on neither one of these forms. So that's why this is neither. Okay. All right, moving on to example 2. So the variables x and y vary inversely. So as soon as you see this phrase, what I like to do is write the equation. Y equals a over x. Varies inversely. All right, that's step one. Step two, we're going to use the given information to solve for a. So y equals 15 when x equals 1/3. So remember that when you divide by a fraction, that's the same as multiplying by the reciprocal. Divide both sides by 3, and we have a equals 5. We use that to rewrite our equation, so we have y equals 5 over x. And then our last step is to solve for our variable y when given the last piece of variable, 5 over negative 10, and that's how we get y equals negative 1/2. All right, example 3. So the driving time between two specific locations varies inversely with the average driving speed. So again, the driving time varies inversely with the average driving speed, okay? So let's call speed R and time T. I would first, step 1, write the equation, T equals A over R. All right, so write a model that gives the driving time T in hours between Chicago and Minneapolis as a function of the average driving speed, R, miles per hour. So notice it does say that the distance between Chicago and Minneapolis is a constant 400 miles. So that does not change. So that's how I know to write T equals 400 over R for number 1. All right, for part B, make a table showing the driving time for the average driving speeds of 32 miles per hour, 40 miles per hour, 50 miles per hour, and 60 miles per hour. So from the previous page, remember we have our equation, T equals 400 divided by R. So we're going to make a little table. All right, so we have our R's and we have our T's. Okay, so we have 32 miles per hour we're going to plug in. We have 40, we have 50, and we have 60. And what I'm doing is I'm going to plug each one of those values into this equation, T equals 400 over R. When I do that for time, I get 12.5, I get 10, I get 8, and I get 6 2/3. And that kind of makes sense, right? The faster you go, the shorter amount of time it should take you to go to a city. All right, let's try our guided practices. All right, so is number 1, direct variation, inverse variation, or neither? Okay, so at this point, you should stop the video and try these on your own. All right, so the answer to number 1, you should get direct variation. For number 2, we can solve and we get inverse variation. And number 3, we can't get into one of our formats, so this is neither. All right, continuing on with guided practices 4, 5, and 6. The key phrase here is the variables x and y vary inversely. So for each one of these functions, you're going to write y equals a over x. And then use the given information to solve for a. So for number 4, when you solve for a, you get y equals 12 divided by x. Therefore, y equals 6 when x equals 2. For number 5, you should have got y equals negative 8 over x. And then solving for y, you get y equals negative 4. And then for number 6, you get y equals 6 over x. And then solving for y, you get 3. Again, in each one of the cases, I'm starting with this generic equation, plugging in the x and y, solving for a, and that's how I get this first one. And then going back and plugging in my x value, 2, to solve for my y. Okay. Our next key concept, the general equation y equals a over x for inverse variation can be rewritten as x times y equals a. So notice we just multiply both sides by x, and that's how we get this equation. So both of these are actually the equation for inverse variation. This also can help us tell if a set of data pairs x and y shows inverse relation, if the products x times y. So if I multiply the coordinates together and that gives me the same constant or approximately constant value, we have an inverse variation. And remember, this is different than when we did it for direct variation. When we did direct variation, we simply divided the y by the x. In inverse variation, we multiply the x times the y. Okay. Now, for joint variation, It occurs when quantities varies directly with the product of two or more quantities, such as the following things. So we have z equals a times x times y. In words, this represents z varies jointly with x and y. A synonym for with you might also see is as. Okay. Again, the equation P equals A, Q, R, S would represent P varies jointly with Q, R, and S. And again, instead of seeing with, you could also see as. Okay. So example 4, let's go ahead and try this one. Okay. So the variable z varies jointly with x and y. Also, z equals 60 when x equals -4 and y equals 5. Find z when x equals 7 and y equals 2. Okay, so first sentence, z varies jointly with x and y. So this first sentence, step 1, I write the equation. Z varies jointly, a, x, y. Step 2, use the given information to solve for a. 60 equals a times -4 times 5. Solving, you get a equals, I think it's going to be 60 divided by -20, which I get -3 if I'm correct. Okay. So then we rewrite the equation. So z equals -3 times xy. Solving for z, so -3 times 7 times 2. And that is how we get z equals -42. All right, example 5. So we're just going to write some equations here. All right, so in part A, write the equation y varies inversely with s. So I would write y equals a over s. For part B, z varies jointly with x and the square root of y. I would write z equals a times x times the square root of y. C, p varies inversely with the cube of q. So p equals a over q cubed. Okay. All right, part D here. M varies directly with the square of n and inversely with p. So m varies directly, so a n squared, and inversely with p. And then lastly, z varies jointly with u and v and inversely with the square of w. All right, so z equals varies directly with u and v, or jointly. So that's a u and a v, and inversely as w squared. All right, how about you guys try this, number 7. All right, so z varies jointly with x and y. So you should have wrote z equals a x y. Using the information given, so 7, you should have got z equals 7/2 xy. And then plugging in the y and the x, you should have got z equals -35 as your final answer. Again, same process here. Plugging into this generic equation, solving for a, you should have got z equals -2xy. And then solving for z, you should have got z equals 20. All right, same thing for 9 and 10. So again, solving for a first, c equals -3/2 x times y. And using -2 and 5, you should solve for z equals 15. For number 10, plugging in for a, so you get z equals 7/3 x times y, and you should get z equals -70/3. All right, number 11, let's try writing some sentences here. So x varies inversely with y and directly with w. So go ahead and try these again, remember, and then see what I wrote. So I would write x equals a over y times w. Number 12, p varies jointly, so p equals a, q, r, and inversely with s. All right, and that's it. So let's summarize the lesson. What are the differences between direct, inverse, and joint? Well, direct, basically y equals ax. Inverse, y equals a over x. And then jointly, you have y equals a times xc, something of that sort. So you have multiple variables in joint variation. Direct kind of looks like this, and the inverse kind of looks like this. All right, and there's your homework for tonight. And you should be able to submit that.